Okay, sure. Hello guys, today I'll teach you how to solve direct variation. And I hope Ashley doesn't get mad at me because I slammed the phone on her. Yeah, definitely. Okay, you won't be asking me right now, what is direct variation? Dude, get out of here. Okay. Let me explain, guys. Direct variation is said to be the relationship between two variables in which one is a constant variable of the other. For example, if B directly proportional to A, the equation is of the form B equals K and A, where K is a constant or the constant of variation. Enough explanation. Solving time! Okay, before we get to solving, there are three things we need to know about direct variation. Which are y varies directly as x, y is directly proportional to x, and y is proportional to x. Which two are the same, but three of them actually has no different formulas though. Three of them are the same formulas. And why do we have to know these things? Because these things need different equations to solve them. And now let's go get to solving. First, we're gonna be doing is write an equation. Okay. Problem number 1. The C cost of fish varies directly as its weight, W, in kilograms. Okay, here's our formula. And how are we going to answer this? Yes, by following the formula, it says here in our statement, the three of ones says y varies directly as x. So y is the first and x is the last. And in our example or our problem, the cost C of fish varies directly as its weight. So if are we going to do this, we're gonna take C and W and RJ. What's the K? Well, the thing here is we're actually trying to find the constant. Yes, we're trying to find the K. So we answer this by putting the C into the Y position. In the Y's position. Replace Y and put there in C. And leave K there, and X replace that and put W in there. That's the answer. And the answer is C equals KW. Okay, problem number 2. The area A of a square varies directly as the square of its side S. Okay, this one is different. You guys are asking me right now, why is there the square of its side? I ran out of jokes. That means you have to put something in it. So, it still varies directly. It means you have to put a square in the side. The S. Yes, the S. Not the square shape, okay? Not the square shape. It's the small 2 thingy. You have to put... It's small, you have to put upwards, not downwards. Okay, how are we going to answer this? So, just like the same one as problem number 1, we have to take the first one, which our first one is actually A. So we have to put A at the first, equals, leave K there, and put the S, which the side is the S. And now it says the square, that I actually said we have to put A squared, and we put S and the squared. Yes, so the answer is A equals KS squared. Okay, problem number 3. The weight W of an object is directly proportional to its mass M. Okay, the formula of this is the same. It's and just like the same as problem number 1 and problem number 2, they're like the same answers, but there's no squared. Like in problem number 2, we have to put squared, and the problem number 1 we don't have to put squared because that's the easy one. We have to follow the formula, and our first one is W, and the last is M. So the statement was put here is directly proportional. W of an object is directly proportional to its mass. So this is the mid one. Yes, the second statement. There we put. No, not really. Okay, the answer of this is W equals, leave K in there, put that K. We don't have to change K because we don't have anything here. We don't have the answer yet because this is just the easy mode. And we have to put the last one is M. Okay, problem number 4. The area A of a triangle is proportional to its height H. Okay, let's translate this. Okay, so our first is A equals is proportional, the constant, which is 0, there's nothing, so we're just gonna put the K. And the last is H. We put H. Yes, that's the answer. So the answer is A equals KH. Okay guys, we have finished the easy mode. But wait, you want more? I'll give you some. Guys, we're in the easy mode again, but we are using tables, not letters. Dude, get out of the script! Okay, where was I? Okay, we're in the tables, right? So we don't have to use formulas anymore because we're just gonna use tables. Yes. Okay, let's go to problem number 1. So we have this right here, which is XY, but this is actually more different. It is actually much more easier than the first one. The first one is we're gonna use -3 divided by 1, which is -3, and -6, and divided by +2, which is -3. Yeah, both are the same, but I'm gonna explain it. Yes, later. Okay, next is -9 divided by 3, which is -3 again. Okay, next is -12 divided by 4, which is -3 again. Well, that means they are direct variation if they're the same. But if all are not same, they are not direct variation. Okay guys, we're in the graph now. Okay, this one is literally the same as the tables, except it's not tables. It's graphs. Same as the tables, you have to divide them. Yes, just the same. Okay, we have our first graph here. Okay, so our graph it looks like, what are we going again? From, okay, I won't, oh, no, not anymore. Okay, so 10 divided by 1, you have to connect them each other. You have to divide them. Example, like 10 divided by 1, it's literally 10. And next is 20 connected to 2, which is x is 2 and y is 20. 20 divided by 2 equals 10. Yes. I'm telling the truth. Okay, 30 divided by 3 is 10. And also 40 divided by 4 is also 10. Yes. It's just like this, guys. It's just like the tables, but this is graphs. They're like the same thing. You have to divide each of them. If they're connected, yes. If they're connected. In the tables, you have to divide them if they're connected vertically. Because that will be very, very hard. If you know what I'm saying. That means our constant of variation is 10. Yes, if they're all the same, then put the same number in it as the constant variation. Okay, guys, that's all for today.